All right, good morning, guys. Today's Tuesday, the 24th. So we're going to kind of take it a little slower today, let you guys get caught up. We're looking to get through the 9-4 stuff. I'm not going to move on to 9-5. We'll maybe get to that tomorrow. So what you should have done, I'm going to go through the warm-up, look at some of the worksheet stuff from 9-4, just make sure you understand it. And then you can go in and do the edge elastics that's on there, and I'll probably post some practice piercing and things like that on in classroom. All right, I'll send out a text and remind if I assign anything new. All right, looking at the warm up today. Yesterday we talked about solving quadratics by factoring. Basically, we got to get this guy equal to zero. Right? If we get something equal to zero, we can use our zero product property. So the first type of questions they give you in 9-4 is it's already factored. Just set each factor equal to zero and solve. So therefore, x is either going to equal -6 or add 5 divided by 3, 5/3. If they say write your answer is in roster form, remember roster form was just and like x equals with the brackets -6 comma 5/3 with the braces or brackets there. That's the only difference, no big deal. If it's not factored, now we got to go back and factor, and hopefully your skills in factoring haven't gone diminished too much. If your leading coefficient is 1, I just look for two numbers that multiply to get 12, combine to get 7, both the same sign, both positive. X plus 4, x plus 3. So set each factor equal to 0. -4 is the solution, or -3, right? If I set them equal to 0 and solve. And then you go ones that are a little bit more challenging. You have your AC method. We got to get going here. So I multiply A times C. Remember, this has to be equal to 0, which it is. So two numbers that multiply get -10. So one's positive, one's negative. To get -9, -10, and +1. 5x squared minus 10x plus 1x minus 2 equals 0. I factor by grouping. I could take out a 5x here. I'll be left with x minus 2. If you remember, if there's nothing to take out, factor a 1 out. X minus 2. 5x plus 1 times x minus 2 equals 0. And then set each factor equal to 0. If I set that guy equal to 0, I would subtract 1 divided by 5, -1/5. If I set this guy equal to 0, I would add 2 to both sides to solve for x. My solution would be +2. All right, there's my solutions there. If you start at a spot where you're not equal to 0, we got to move this guy to the other side, actually both of these, so this ends up becoming 6x squared. Add 2x to both sides, so -7x. Subtract 20 from both sides. Now I got to equal to 0. And now I got to find two numbers that multiply to get me 120, which is negative, so the signs are different, combined to get -7. Let's see, so if I look at that, I know 12 times 10, but they're only 2 apart. So 15 times, I grab my calculator. So 120 divided by 15 is 8. There you go. 15 and 8 are 7 apart. I want the 15 to be negative. I'm going to plug these guys in. 6x squared minus 15x plus 8x minus 20 equals 0. We factor by grouping. Let's see, we can take a 3x out of that guy. I'll be left with 2x minus 5. I could take out a +4 here. I'll be left with 2x minus 5. I use my distributive property here. I group these guys together. 2x minus 5 gets pulled out. And now I set each of these factors equal to 0. I would subtract 4 divided by 3. So x could equal -4/3. Or add 5 divided by 2. I get 5/2. Okay, there is that solution. I know the warm-up's a little longer today, so I just wanted to practice some of these different problems. If you can factor stuff out first, remember that makes your life easier. Take that 3 out, you get x squared minus 6x plus 9 equals 0. If you recognize this, this ends up being a perfect square trinomial. right? It's going to be x minus 3 times x minus 3. If I spoke about this yesterday in notes, if one of your factors doesn't have an x in it, I really can't make that guy 0. So either this guy's 0 or this guy's 0. In this case, x equals 3 is the only solution, because when I set that equal to 0, it's 3, or that is 3. Just to show you how you can check this too on Desmos, if I typed in that quadratic, it was 3x squared minus 18x and plus 27. And I could put equals y, or y equals, and what happens is, whoops, I plug that in, and it graphs it. And you'll notice that that's why they call them the zeros. X is 3 when y equals 0. So think about that. If we plug 0 in for y there, we have the equation we started with. So really, what we're finding in all these cases are the x-intercepts, or the values where you cross the y-axis. All right, so if I were to try another one of the ones that we did already, I'm going to plug 5x squared minus 9x minus 2 equals 0. All right. Oops, there we go. Blurry for some reason. All right, there we go. If we plug this guy in and see where the zeros are, you're going to see we're going to cross the x-axis at negative 1/5 and 2. So if I typed in 5x squared minus 9x, Getty, plus minus 2, I could put equals y, if I wanted to, but there we go, and it's graphed, and you'll see there's the one solution of negative 0.2, that's my negative 1/5, and there's my other solution of 2. All right, so that's why we call them the zeros or the roots. So you can always check on Desmos if you had to. All right, looking at, it's a little bright there. Let me turn the brightness down. All right, well, this one, notice there's no b, so we have a couple ways of solving this guy. If I were just to get the 36 to the other side now, since there's no b, we're going back to 9/3. We could divide by 25, divide by 25, x squared equals 36 25ths, and then take the square root of both sides, and the square root of 36 25ths would be 6/5. Don't forget it's plus or minus. Okay? The other way of solving that is recognizing it's a difference of squares. This is 5x plus 6 and 5x minus 6 equals 0. So subtract 6 divided by 5, it's negative 6/5. Add 6 divided by 5, positive 6/5. All right, and if you can factor, again, we factor first. Let's take a 2x out of this guy. I'll be left with an x squared minus 10x plus 24 equals 0. This factor is done, but notice there's an x in this guy, so I'm going to bring that guy down. Either way, I still bring it down. And then this one, I could use mental math to solve this. Two numbers that multiply to get positive 24, same sign. To get negative 10 would be negative 6, negative 4. So using my zero product property then, I should have wrote that up here a little bit. My solutions then, if I set this guy equal to 0, I do have an answer now. 2x equals 0. So if I divide by 2, right? So if I solve this guy, 2x equals 0, x would equal 0. There's one solution. X would equal positive 6 with this one, and x would equal positive 4. This guy actually has 3 roots. It was a cubic. Once again, if you want to check that, you can go ahead and plug in on Desmos and see what happens here. Pretty neat stuff. Desmos is a really powerful tool to be using. I'll go back to the original problem. It was 2x cubed minus 20x squared plus 48x. And now you'll notice if you look at the graph, there's one root of 0, there's one root of 4, and there's one root of 6. There are our roots that we just found. Okay, so again, use Desmos if you need to. And then they give you a couple different problems, like one that says write an equation in standard form, quadratic equation, standard form, that have a solution of 8 and negative 3/4. So think about that. It's actually easier to start this way. So if this was x minus 8 is one factor, if I plugged 8 in here, that makes that 0. What's the other factor if I'm going to get over here? Think about how we solved like up here. This guy was, solution was negative 4/3, so it was plus 4, so it's the opposite of that, and then that guy's your coefficient. So it's the opposite of up here, so I'm going to be adding 3, and that guy was my coefficient, it was 4x. So think about that. If I were to subtract 3 and divide by 4, I would get negative 3/4. Now, because it's a standard form, FOIL this guy out. 4x squared minus 32 plus 3 is minus 29x, and then minus 24 equals 0. If I factor that guy, I'll get this, and if I were to use my zero product property, I end up getting positive 8 and negative 3/4. All right, so looking over your assignment, finish up. This first part they're already factored for you, so just set each factor equal to 0, 3m equals 0, 2m plus 9 equals 0, and solve, so I get 0 or negative 9/2 for that guy. This next section, factor. Make sure you get it set equal to 0 first. If it's not, get everything to one side, then factor it. And some of these problems, you're going to get answers, especially like these word problems, when you set them up. You might get a negative answer, and you're asking yourself, how can something be negative for this to work? Like if the volume or the length of something is negative. They're called extraneous answers. So if you get a negative solution, like for example, let's see here, if we were to do this guy here, the volume of the sandbox is shaped like a rectangular prism. All right, volume, 3-dimensional, and it's 48, so volume equals 48 feet cubed. The height of the sandbox is 2 feet. The width is W, and the length is W plus 2. All right, so what we want to do then is we want to use the zero product property, and if I just set this up here, this times this times this, so I'm going to do W plus 2 times W times 2 equals 48. So if I were to multiply this out, I'm going to end up getting W squared plus 2W times 2 equals 48. And then if I get here, I get 2W, I'm distributing in, plus 4W minus 48 equals 0. So I get a quadratic that's set equal to 0, and I can solve this using my zero product property. I could factor a 2 out. I'm running out of room here, but if it's say factor a 2 out, I'm left with W squared plus 2W minus 24 equals 0. So let's see, two numbers that multiply get negative 24, and it's going to be W plus 6, W minus 4. And now using the zero product property, this will give me solutions to the original problem I had. So W could equal negative 6 or positive 4, and this is what I'm talking about. Since W is a width, W can't be negative 6, even though it's a solution to our quadratic. That's called an extraneous answer. We don't want that guy. So our answer for this would be W is going to equal 4. We don't care about that negative 6. It's an answer to the quadratic, but it's not to this real life problem. So think about it. In our vertical motion models, this happens all the time. If we were to launch an object from a certain height, it's going to go up and down again. If we were to watch put that quadratic out, you're going to get, the time it takes to hit the ground, you're going to get one answer over here and then one answer over here that's negative. It can't take negative time. That's just a model, okay, of the general quadratic. But in that real life problem, we would just disregard this answer and only take that one. All right. So in those real life models, you got to watch out for extraneous answers. All right, but get the idea on these down here. Just set them up, get your quadratic in standard form, and use your zero product property. Same thing happens here. All right, and then do the best you can with those down there. Like I said, today we're going to kind of sit pat and let you guys go forward with the 9.4 stuff. All right, so keep hanging in there. Send me any questions you have in regards to the 9.1 through 9.4. Go onto the edge elastics, get the edge elastics for 9.1 to 9.3 done. Tomorrow, like I said, we'll probably get into start completing the square, which is going to take a couple of days. And that'll be our plan going forward. All right, guys? All right, email me with any questions. I'll see you tomorrow.